Hello everyone, my name is Sérgio Freitas and I'm going to be talking about iterators, especially in JavaScript. First of all, what are iterators? Iterators are mechanisms that allow you to traverse collections. They are stateful, which means that you can pause the iteration. Therefore, you have a state which allows you to get the current element, check if it's the last element, and move forward. They are usually built into the language, and they can provide lazy iteration, which is also a big topic in this presentation. What is lazy iteration? Lazy iteration is when you don't want to materialize the whole collection, which means that you want to iterate an element at a time and only materialize the element fully when you're reading the specific element. This allows you for immutable collections, and also your code isn't fully executed when you're doing your mapping, your filters, whatever. In JavaScript, iterators do not have an interface because, you know, JavaScript is not a typed language. Therefore, you have a protocol. This is quite different from most languages. The protocol is simply using a symbol.iterator, as you can see here. And then you return an object which has a function called next. And in this return object, you have a value and a done. Value is the current value, and done indicates that you're done. There's nothing else to advance. Okay, so I'm going to show you how to create an a lazy and an iterator in JavaScript. So first of all, what are the pros of using iterators? Iterators are an abstraction over collections. There are already some collections in JavaScript that already implement a protocol, the iterator protocol, such as arrays, sets, and maps. And this allows for better performance when you're not using the whole collection, or when you just want to do successive maps and filters, but you don't want to materialize as many arrays as you're calling these functions. Some cons are transpilation, which when you're using especially generator functions and for-off loops, they transpile to really, really poor code. And these can also hide context loss, which means that when you're iterating a collection that has a connection to a database, if you lose that connection, you can end up having a really messy error that you cannot really trace what's happening. So I'm going to show you some JavaScript code on how to do these. This is a simple implementation of the iterator protocol using a Fibonacci sequence. So you can see here that you have this object, which is your iterator, and it has a function called next, and it returns the object with the value and done properties. So here is where you advance. When you call the next function, you advance to the next value, and here you show the next value. And as this is a Fibonacci sequence, it never ends, so done is always false. This is also a really nice thing that you can do with lazy iterators. You can have infinite collections. So let's say if you'd want a collection with all prime numbers, you could use a lazy iterator. Using generator functions, it's a built-up feature in JavaScript with ES 2015, I think, and this allows you to have a much simpler syntax to write the same exact code. However, as I'll show you, this transpiles really poorly. However, you use the yield keyword to return the current value. This is a little strange because it's really abstracted, because it does exactly the same thing as here, but it abstracts you from the iteration aspect of things, of the done and the next. You just return here always the current value. Okay, this is how you transpile a generator function. This is not pretty, as you can see. Okay, so I'm going to show you differences of performance differences between eager and lazy. I'm going to show you a library that I did that implements most of native JavaScript's map, filter, reduce, etc. functions called forofa. I'm not going into much depth about this library, but this is an open source project that I've done. And here you can see how you do it in native JavaScript with eager functions, map and filter, and below with forofa. It's pretty much the same syntax. However, at the end, you have to materialize your collection. So I have created a function to array. when you do an eager iteration, this is what happens. When you do filter and map, you have an array, then you have another array, then when you filter, you have another array. So this is when you map an array of strings to an array of integers, as you can see here, and this is when you filter. So you end up with 3 arrays. So you need like 3n type of memory. This is what happens when you do a lazy iteration. When you do the functions, you're not actually doing anything. You're just wrapping your collection inside the function that will return an iterator. So you can, when you do these, there's actually no cost. It's just a small overhead, which you're not really doing anything. You only materialize when you start iterating or when you transform it to an array. This is what happens when you materialize with a lazy collection. So let's see, you're starting your iteration, you're going through the first value, you do the map function, you transform one string to 1, then you filter, it's false because we're only checking for odd even numbers in the example. And here you see, you iterate to the next one, 2, you map 2 to the number, and it's an even number, so you return 2, and you show 2 here, and so on through the whole collection. As I said, Farofa implements most, or actually quite some of the JavaScript native array transformation functions. You can see each can check the library here. And in conclusion, I'm going to show you some performances differences between lazy collections and eager. So here you have the code using Farofa in lazy, and here eager, it's pretty much the same code. As you can see, it's only like, there's a difference with toArray, and also instead of doing a slice, I'm doing a skip and take. It's pretty much the same thing. And as you can see, with really starting with most collection sizes, it gets really much more performant, or performance is pretty much equivalent. But with really large collections, you can see a really big difference here. This is the worst case scenario where you don't slice, you just iterate through the whole collection. So performance difference isn't as visible here, but it starts getting visible when you get really large collections. And that's it.